Now let's go over example 2, which is very similar to example 1. We want to find the inverse of f of x both graphically and algebraically. Now we have again already graphed this before. 2 to the negative x. If we go back to module 4, lesson 3, down here, we change this to 1/2 to the x power. We found these values, which we got to by graphing. We change this to negative x. Here's my graph. And I went here to my table and copied down some values. So I just took these values here and put them here. And I went ahead and already plotted those. So if you want to pause the video and get those plotted so you can get caught up. And just like before, we have another horizontal asymptote. So before we connect those lines, let's draw in that horizontal asymptote at y equals 0. Okay, so when we connect those points, we will not cross that x-axis. Okay, there's my graph. Now the domain. Okay, the domain as I go from left to right is negative infinity to infinity. The range as I go from the bottom to the top, the first thing I encounter is that horizontal asymptote. So 0 to infinity. And then again, horizontal asymptote at y equals 0. So that's all a review from what we did 2 lessons ago. So now graphically, let's find the inverse. We do that by taking our x values and rewriting them as our y. And then rewriting our y as our new x. Okay, let's graph these. And just like before, as these x values are getting smaller, these y values are going to get higher and higher, but they are never going to touch this number right here. So we have a vertical asymptote. And we have a, where do I want to write this? A vertical asymptote at x equals 0. So when we connect, we are not going to cross that y-axis. Now this one looks a little bit more funky when we put it all in one. And by the way, let's label these, right? This is my inverse function. And this is my function here in blue. And let's put our line of symmetry, which is y equals x. All right, so we have a complete graph now. Okay, so let's finish filling out domain and range. We already have our asymptote here. So our domain As you go from left to right, the first thing we encounter is this vertical asymptote, and then it's going to keep going on to infinity. So this is 0 to infinity, which is the same as that range. Then we're going to switch places. Our range, going from the bottom to the top, goes from negative infinity to infinity. Which is the same as the domain. Okay, so you can either look at the graph or just switch them for here. So now let's do this algebraically. Before I do this algebraically, I am going to go ahead and rewrite this in its more proper form, which this is the same as f of x equals 1/2 to the x power. So down here algebraically, that's how I'm going to write this. F of x equals 1/2 to the x power. So let's figure out algebraically what to name our inverse function that we just graphed right here. So here are my steps again. First, replace f of x with y. Next, we're going to interchange our x and our y. So this is x equals 1/2 to now the y power. Step 3 is to solve. I can't solve for y because it's in the exponent position. What I have to do is rewrite this. So when I rewrite this, this goes from base to the other side of the equals. So this is log with a base of 1/2 of x, and that equals what's left over, y. So now we've solved for y is by itself, and now replace y with your inverse notation. So the inverse of x equals log base 1/2 the x power. So if you notice, there's definitely a correlation right here. When I have an exponential with a base of 1/2, it's a log with a base of 1/2. Last video, when I had an exponential with a base of 2, I had a log with a base of 2. Let's kind of look what these different graphs look like when I go over here to Desmos. So I'm going to unclick all of these that we did last video. Here is my log with a base of 1/2. When I have a base of 1/3, it shallows out again and goes, kind of horizontal a lot quicker. To the 1/4 is right there. And then 0.2 would be to the 1/5. It's even, it levels out even quicker. Again, they all have the same things in common that all of these ones up here did with a base greater than 1. They all still have an x-intercept at 1, 0. And they all have a vertical asymptote at x equals 0. And so if I actually just go ahead and click all of them, no matter which type of graph we have, you have an x-intercept at 1, 0, and that vertical asymptote right here at x equals 0. So we will get graphs that look like this in the red every time that I have a base between 0 and 1. Base between 0 and 1 means that we will have a graph that is always decreasing.